Okay. See, there's a few people here. How's everybody doing? So again, I'm trying this out to see how this will work for people here. Kind of see what this is. It's going to look like. Okay, good to see you guys joining here. So let's take a couple moments here. Are there any questions about logarithms or anything like that? Now, bear in mind, there's not much to say about kind of the situation that we're in. We'll see. We have to wait and see kind of what decisions get made. We know not much more than you guys about how we're going to handle this. But I'm hoping that you're keeping somewhat up with the lessons, the videos. So I was hoping that we could try this out as a Q&A, a question and answer scenario here, and see if this would work to help you kind of keep up with the material. So I can see some people online right now. Do you guys have any questions? Is there anything, for example, for my students in particular, if you've got questions from the workbook, that would be easy here. Now I've got an older version of the workbook, unfortunately. So if you kind of tell me what lesson we're in here or what the question is, we can go from there. The nice thing is about the asking the questions on the chat there, the live chat there. People can look at it later on and see what has gone on here. So anything special about complex logarithms? Now, just so we have context here, maybe what is it that when you say complex logarithms, I believe that really all we're referring to at this point for particularly my class, a complex logarithm would just simply be something that maybe had like multiple logarithms in it. There's really nothing unique about that. Remember, you're going to use your log laws to combine expressions together, right? I'm just concerned when I see that complex logarithms there. I'm just concerned that there might be like this might be coming from another course where that's being used a little bit differently. So it's hard to say what. Oops, I am way beyond in the workbook here. Okay. With when you say complex, I was a little nervous that was the discussion that was going towards. For the class that I'm working with right now and trying to get caught up on this, we're not looking at imaginary numbers. So that is something I'm happy to explore in a different context. Certainly happy to explore it. It's awesome. Those are really interesting here. But for right now, I'm working with a group of students that they're just seeing logarithms for the first time. And so so I want to see if we could use this as a platform to, or how useful this would be as a platform to help those students. So I apologize for that right there. It's just right now that wouldn't be the intention. Is anybody from my group that has a question? I mean, if not, then maybe what I'll do. I appreciate your understanding with that. Okay, well, I tell you what. Let's take a quick look at. Okay, yeah. Okay, I tell you what, Brody. While you're looking that up here, what I'm going to try doing here is on the Google Classroom that I had set up here. I've posted some of the assignments that you would have gotten from me this week, and one of them was you would have gotten the logs and exponents checkup, and then you would have gotten the manipulating logs sheet. I want to take a quick look at like a manipulating logs question. One of the questions from the first part of that assignment there. So the way that the question is worded is it says that the log, I don't know why I did it like that. Hold on. It says that the log base a of 2 is equal to x, and then the log base a of 3 is equal to y. And then we're supposed to express these other expressions here in terms of a and y there, or sorry, x and y. So for example, let's take a quick look at if I give you the log base a of 3/4, based on the information that you've got right here, okay, how do we rewrite this expression in terms of the other two logarithms there? And we had gone over this in class. I just want to review that. This is the way I want you to approach that is using the laws of logarithms. I want you to separate that out. So we know that division within a logarithm, okay, division within a logarithm becomes subtraction between logarithms. Okay, so the division within the argument of a logarithm becomes subtraction between two different logarithms there. Now, this is still not perfect because I'm not seeing the log base a of 2 in there. But I know that 4 is 2 squared. Okay? 4 is 2 squared. So now I've pulled out that log base a of 2 out of that. Now, don't do this, though. Don't make it kind of the snap judgment. You think, okay, I've got log base a of 3, so it's going to be y. And then this is going to be x squared. Okay, that's incorrect. The reason it's incorrect here is because x is the log base a of 2. Okay? Over here, what is it that's being squared? Is it that the log? So what you've kind of got to do with this first is we got to bring that exponent down. And now this is 2 times the log base a of 2. That's going to be y minus 2x. Okay. Now, I tell you what, this is going to be a little bit awkward here. Oh, I'm sorry. I was one now. Brody, I see your question here. I got to run and pull that up. Realize that well, here, I'll try this. Extra practice 2D. So, Brody, I'll put the question up on the board here. But I need you to verify that I'm looking at the right one. So please let me know immediately if I'm writing this down correctly here. It's the log base 3 of x minus the log base 27 of x equals 4/3. I just want to know that I'm looking at the same one you are. Okay, good. I'll run with that. Always someone who asks about going to the bathroom. No, you can't. Whatever, that doesn't matter. Okay, so here we go. Let's take a quick look at this one right here. I can't really do much with this equation, and you've probably figured out why. I mean, this is probably what inspired the question here. Because you're dealing with 2 logs with 2 different bases, okay? As soon as you got different bases here, well, that's they don't mesh together like that. So I have to make that work. So what I'm going to do, it's easy enough to do this in this context because this is base 3. Well, I know that 27 is a power of 3. So what I can do here is use my change of base rule. Now I'm going to put that off to the side here. Remember your change of base. Okay, we know that the log base b of a can be written as the log base c of a divided by the log base c of b. And actually, I appreciate you asking this question because one of the things that I was going to go over with you from the manipulating logarithm sheet was something related to that. So this is gonna mesh together quite nicely. So here, I want to convert this into log base 3. So log base 27 of x is going to be the log base 3 of x divided by the log base 3 of 27. And that's still equal to 4/3. Okay, well, I know what the log base 3 of 27 is, because I know that 27 is a power of 3. Okay, it's a nice one to evaluate here. I know that 3 cubed, okay, is equal to 27. So now this is going to become the log base 3 of x minus the log base 3 of x over 3 is equal to 4/3. Okay, remember, the log base 3 of 27 is going to be 3. And now at this point, what you've got are these two unknowns right here. This log base 3 of x, it shows up twice here. But you really just want to treat that as an unknown. What I might be tempted to do at this point here, because we've got, denominators there, I'm tempted to multiply this thing through by a 3 to get rid of that. So we're left with 3 log base 3 of x minus the log base 3 of x is equal to 4. Well, here, 3 log base 3 of x's minus 1 log base 3 of x is going to be 2 log base 3 of x is equal to 4. And now you can probably see where this is going. We're going to divide by the 2, and then we're going to convert, and we're going to get that x is equal to 3 squared. And remember, no matter how much in your gut you might look at that and say, it's 6. It's not 6. It's 9. Okay? So there we go. Hopefully that makes sense. Okay, so Brody, you asked that. So if that doesn't make sense, just kind of let me know, and maybe let me know what step. So weird to think of it like this, but let me know what step didn't make sense, and then we can go from there. Okay, you got it. Okay, good. So along that line, and actually I'm really glad that he asked that, on that sheet, that manipulating log sheet that I provided for you guys, or I shouldn't say everybody there, because some of you are clearly not students of mine. For those that got it, then you'll see this. One of the questions that you get here, and I'll give you the lead-in information again. The log base a of 2 is equal to x. The log base a of 3 is equal to y. One of the questions you got was D, and it was the log base a of 2a over the log base a of 3. Okay, so this was question D. And I want to look at this one here because there is going to be a temptation to do something slightly incorrect here. There is a temptation to look at this division here and think that it's related to subtraction. Okay, I see students do that quite a bit. I mean, and I get it. Okay, you spent a bunch of time trying to get the log laws clear in your head, and you know that if you've got the log of m divided by n, that can be rewritten as subtraction. But notice how the division works, and that this is different here. This is division within a logarithm. This is division between two logarithms. It's not that rule. If anything at all, it's this rule. Now, to simplify this, I actually don't want you using that rule, but I wanted to identify that this is more in line, this has more in common with this relationship than with this one right here. Actually, what we want you doing with this one is just treating them separately. In the numerator here, because there's multiplication within that logarithm, this becomes the log base a of 2 plus the log base a of, oops, sorry, I'm anticipating the answer, a over the log base a of 3. Okay? And now I've pulled these pieces out. We know that the log base a of 2 is going to be x. We know that the log base a of a is 1. And the log base a of 3 is y. Those two we know because of the definitions we're given initially in the problem. And then the log base a of a, remember, that's like an idol. That was an interesting question right there. Oh, and by the way, at the end of that, I mean, I might as well tell this to you. There's another question at the bottom of that page. Really, I was just being a jerk when I put that on there. The last question there is J, log base A of 5. I'm asking you to look at these values here to get 5, right? Well, 2 and 3, how do 2 and 3 combine to get you 5? Well, they do like this, 2 plus 3. But you see, this is a bit of a trick. This is a trap. I'm kind of baiting you. I'm wanting people to do this incorrectly. Logarithms don't distribute. I cannot, now watch when I do this. I cannot say that this is the log base A of 2 plus the log base A of 3. That doesn't work, because if that was true, I know that addition between logs becomes multiplication within a log. And then this would go backwards to the log base A of 6. So I know this rule works this way. It clearly implies that the logarithm does not distribute across that set of brackets right there. So you wouldn't do that. So this is actually a dead end. I cannot do this. I cannot rewrite this in terms of x and y, at least not in any kind of straightforward way that we would expect from you. So you would just write here. There's no solution to this particular problem. Okay. Okay. Now I've just been kind of blah blah blahing here for a few minutes. Does anybody else have a question? Anything you want me to go over? Oh, well, I appreciate that. I can't tell who you are from Dragoonix, but thank you. Appreciate that. See, I'm tempted to ask what you're up to with your life here, but I gotta focus on this for just a little bit here. Anybody from my class have any questions? Let me see if I can grab one here that I feel deep in my soul we need to go over. Okay, Simon, you should be, so what was going to happen this week on Monday before everything kind of went off rail here? We were going to spend the day going over this, okay, this is a sheet that I have posted on the Google Classroom. Yeah, thanks, Brody. Yeah, it is on there. So if you go to the school zone, well, it should be like a day-by-day list of the things that we're supposed to do. Now, the outline is based on what I would be teaching from. So, but it does give you a sense of what order we would be progressing through this course if this wasn't happening. So we kind of want you to just to stick to that. So like when it mentions quiz, I will probably have that posted on the Google Classroom. Now, as to how we're going to assess that, I don't worry about it at this point in time. Just use these as extra practice. Okay, Emma, see, and we're going to have to talk to teachers about that. That might be an option, is for you to take the quiz, take pictures, and then upload them so that I can take a look at it and mark those. After the break, we'll probably have a clearer picture of how we're going to handle the assessment. At this point in time, I don't know, and we're kind of waiting to be given some direction with respect to that. So with the quizzes and stuff that I post, and I'm going to try not to overwhelm you guys and just do a little bit at a time here. Integral of arctan. No, I'm not doing that right now. Appreciate the question. I'm curious as to who that might be. But for my class right now, I'm going to give you the quizzes kind of as they would normally come up. I encourage you to go over them. I might, Emma, I might just end up posting the key so that you can kind of check your own work as you go. But I would post it and then give you like a day or two before I would post the key. again, we're still waiting for a little bit more direction here. We're kind of, as everybody has said over and over again, we're in uncharted territory here, so we don't know. Well, Armand, that's a good question. For right now, it's just my class. I'm not sure how we're going to approach that. We may end up amalgamating them. It's just that for right now, I did my own only because I'm very likely to use quizzes and assessments that other people wouldn't use. So what we're supposed to do this week is kind of treat it as if all of you are homesick. So right now, this is just a tool that, yeah, sorry, yeah, that calculus question. I would love to answer that calculus question. Don't get me wrong. Don't get me wrong. But yeah, right now I got a different goal with this particular lesson here. So, yeah, but Armand, back to your question here. I suspect after the spring break, things will be a little bit different, and we'll probably be given more of a clue as to how we'll do this. I suspect if this continues on, what we will do is we will teach like Math 30, not per class, but as a group. But I don't know. I'm just kind of spitballing here. So we've talked about that. We're not quite sure. So yeah, for the time being, I'm supposed to treat this as if everybody's homesick. So this is just my class. This is what we would have done this week. And we'll go from there. Do you guys want to, should we try solving an exponential equation? Or I tell you what, someone give me a kick. I will go through, this is Mrs. McIntyre's thing. Yeah, I know. So sorry, this is to answer Brody's question here. When it comes to working with full year and semester courses, yeah, exactly, we would have to separate those out. So there would be a Math 30-1 full year, a Math 30-1 semester. Yeah. I mean, clearly we'd have to break it. You guys are at very, very different places. Now, oddly enough, if this is how we do it, by about the time we get to near the end of May, you guys start to mesh up. So we could probably pull everybody together at the end. You probably wouldn't, but that is a possibility. So you want to try like a log equation or a exponential function, like an exponential equation? I tell you what about the IB stuff? Oh, guys, I want to do math. Yeah, the IB stuff, that is going to have to be. Tara, if you wanna audit, by all means, you're welcome. The IB stuff, I am going to have to deal with in a bit. Yeah, particularly for you guys, because we need to get through the statistics stuff. Oh, we got to get through the statistics stuff. I will post videos. Right now, I have to focus on the 20-2, getting those videos up to speed. And then I've got to do some work with another course here. And while I'm doing that, I'll be alternating between that and the IB material. So I will be posting videos for the IB material. Actually, no, I'm not teaching university students, although I have answered questions. I am specifically a high school teacher. So. I love the university material, though. It's awesome. You should all be going to university and studying calculus. It's good for you. It's good for your soul. So I'm going to circle back to the question I had a few minutes ago. Anybody want to see a log question done? A log equation or an exponential equation? I was going to use Mrs. McIntyre's sheet as an example. Oh, thank you. Exponential function. Done! Okay, we're going to do an exponential equation here. Okay, so in Mrs. McIntyre's, in her, well, actually, she's only got, she's got a fairly simple one here. So I'll tell you what, I'll do the one that she's got here, and then what I'll do is I'll come up with one. I'll make one. I'll make one up. So the one that she's got here is 4x equals 19. Okay. So 4 to the x is equal to 19. We'll just do this in two different ways there. Okay. Okay, well, yeah, see, logs, it's relevant. I hope my students are reading that as well. You're seeing that this is relevant. It is helpful here. So let's take a look at 4x to the 19. There are two ways you can approach this. It doesn't really matter from my perspective how you go about doing this. One way is to simply take the common log of both sides of the equation. So we treat the log function as if it's well, not as if it is an operation. I'm going to apply it to both sides here. The reason why we do that is because it allows us to bring that exponent down. Okay, that's one of the laws, right? One of the logarithm laws there is that I can bring that exponent down. Now, what we just did there is very like what you would do if you knew, for example, the square root of x is equal to 4. What you would do is you square both sides to get x is equal to 16. Okay, it's very, very similar to what we're doing there because we're applying a function here that is the inverse of that exponential. Now, at that point, whoops, sorry, don't know why I did that. X is going to equal, I'm going to divide. Don't get too caught up in this. Okay, a logarithm of a number, a logarithm number, those are just constants. They're just numbers. Now, I don't know what those numbers are. My calculator does. And so if at any point in time I needed that, I can plug that in. But the log of 19 is just a number. The log of 4 is just a number. So if I want to get x, I would divide by the log of 4. Now, at this point here, it depends on what the question's asking. You could do one of two things here. I could actually get the decimal version of this, which I'm not going to because, quite honestly, my calculator's at the other end of the room. So I'm going to leave it there for right now. But this is also, I could use the change of base here. This is going to be equal to the log base 4 of 19. That's that rule that we were looking at just a few minutes ago. So that's one way to do it. The other way that we could do this, it's a little quicker here, but it really works in only a limited set of circumstances. I could simply convert this into its log form. So the base is 4. So my base here would be 4. The exponent is x. So and a logarithm is an exponent. And then I'm taking the log on the other side there. So, I mean, I can just convert that to the log form and I'm done. I mean, it's a very quick jump to there, quicker than it is here. However, a lot of people are going to be more comfortable with this than they are with that. It's a conceptual thing. If you're not super comfortable just making that switch, this is an easy thing to do here. Now, that's one way this question could get asked. Now let's make up one. And this is going to be I don't know if this is going to work all that well. I'm just going to pull this kind of one out of the air here. Let's say you've got 3 to the x plus 2 is equal. Actually, let's say it's we'll do it over here. Is equal to 4 times 2 to the 5 minus x. I don't know. I'm just pulling this out of the air. So we'll see what happens here. Now, I've got two different powers. The bases are the same. They're not related. What should I do here? Well, first of all, I want you to see what you can do here. Actually, sorry, I'm going to do this differently. I'm going to do this in two different ways here. The first way I'm going to do it is similar to what I did in the last question. I am simply going to take the log of both sides. Okay, so I apply that operation to both sides of the equation. The reason that's useful to me is because of the next law, I can pull down, okay, the exponent out in front here. So I can make this x plus 2 multiplied by the log of 3. Now bear in mind, this is wrong the way I've written it. And I know I've gone over this a lot with my students here, but this is incorrect. The reason it's incorrect is because written like this, the only thing being multiplied by the log 3 is the 2. But I need that whole exponent to do that, so I got to put parentheses around that to make sure that it's that whole exponent being multiplied by the log of 3. Okay? Now, over on the right-hand side, it would be very tempting to want to bring that exponent down. But the power is just 2 to the 5 minus x. Okay? It's just 2 to the 5 minus x. It's not including the 4. So I can't just bring down the exponent until I've done this. Okay, until I've split that up into a product. And then what I can do is bring that exponent down. Okay, now I really have no idea how nicely this is going to clean up here. So, yeah, we'll see. So now let's distribute this through. So x log 3 plus 2 log 3, okay, when I distribute that through, is equal to the log of 4 plus 5 log 2 minus x log 2. Okay, so now I've distributed the logarithms through. What I want to do now is get my x's together. Okay, yeah, sorry. Sorry to break the news to me. What's this? Sorry to break the news to you. Sorry, I've been going back and forth here trying to read, but it's hard to kind of keep up with everything here. Okay, I'm going to keep going until I see something new here. I got to get the x terms together. So I'm going to bring the 2 log 3 over. I'm going to bring the x log 2 over. Okay, so x log 3 plus x log 2. I'm going to bring the 2 log 3 over. So now I'm going to get this kind of a mess over here, but I'll deal with this in just a second. Okay, I will deal with this in just a moment here. Now I'll factor out the x. Okay, now on the right-hand side here, and I got to try to get this. Sorry, yeah, question? Or is there a question? SA? Okay, I don't know what's going on here. So anyway, on the right-hand side here, to simplify this, remember for my students here, remember how I've described this. I should be able to get this into one logarithm in at most 2 steps. If you're taking more than 2 steps, you're taking a scenic route through this problem, so don't do that. So the first thing I'm going to do is bring the 5 up as an exponent, and I'm going to bring the 2 up as an exponent. Okay? Over on the left-hand side, I know that addition between logarithms is multiplication within a logarithm, so this is going to be log of 3 times 2, so 6. And then over there on the other side, okay, this is going to be, here we go. Addition becomes multiplication, and then subtraction becomes division. Wait. Okay, well, this is kind of ugly, but I apologize for that. But this is what happens when I just make things up on the spot. Okay, it's going to get a little bit out of control here.
Nice and scenic, though.
It is. It was the long route there. So now x is going to equal the log of, okay, well, 2 to the 5th. See, I feel like I need to ask people what the answer is, but anyway, 2 to the 5th is 32 times 4. I know what you're saying, 128. And then this will be over 9, and we're going to divide that by the log of 6. And then this is, using my change of base formula, okay, and there we go. Yeah, thank you. I do have one student here. Actually, that's not true. This is Mr. Garkey. Oh, yeah, so, yeah, Kenny, I do have one person here. That's it, and he's not even a student. Now, if there's no questions about this, oh, I gotta take a look at this. Okay, the question is, how did this become this? remember that the log of 3, everybody, is just a number. It's just a value. So it's like having like a 7.2 here. All I did was distribute this backwards to the 2 terms in the binomial. That's it. Okay. Did I turn a 2 into an x? Did not turn into an x. This came over here, and then this 2 log 3 came over there. Those 2 terms switch sides. Yeah, x log 3 from here, and then the x log 2 came from over here. This term moved over. Okay, so remember when you, can you do another? Yeah, I want to show you guys something here before I move on to let's say a logarithmic equation. I'll do another one here, but I hope everybody sees what happened here because I don't want there to be confusion here. This log distributed to those 2 terms, and then I brought that one over. It just changed sign over here, right? When you move it from one side of the equation to the other, it changes signs. Okay. Now, if we're okay with this, I want to show you another way you could have done this problem. I'll show you now. We're going to get to that answer again, but we're going to do this a little bit faster. What I'm going to do is I'm going to rewrite the expression. I'm going to get the x's together first. Maybe I will, maybe I won't. Now I don't want to. But what I'm going to do here is I'm going to use our exponential or laws of exponents here to get the x term together first before I go to a logarithm. So 3 to the x plus 2 is 3 to the x times 3 squared equals 4 times 2 to the 5 divided by 2 to the x. Okay, I hope that makes sense. I hope that makes sense because oftentimes I have students that will look at that and they will say, nope, don't know what happened there. Okay. But what's going on here is very simple. If you've got a to the x multiplied by a to the y, that is equal to a to the x plus y, which is equal to a to the x times a to the y. And I do this frequently with my classes. Most people are very, very familiar with this rule. Not so familiar with this rule. Been doing this one for years. Totally get it. This is when we started learning exponents. We did this one. Never seen that one before in my life. It's just the same rule. I'm just asking you to go backwards. Okay, that's it. Okay, so now, sorry, which question there? How can we make 4 into 2 to the 2? Wow, okay, we can do that. I can totally do that, and that's fine. But I'll deal with that in a second here. Now what I want to do is I want to get the x's together here, and I'm going to bring the constants over. So 3 to the x multiplied by 2 to the x will equal 4 times 2 to the 5th. And for those of you that are desperate, we'll do this. Okay, and just make that 2 to the 7th. There, 4's gone. Over 3 squared. Okay. So now, when I put those together, this is going to be 3 times 2 to the x equals 2 to the 7 over 3 squared. 6 to the x is equal to 2 to the 7 over 3 squared. So x is equal to the log base 6 of 2 to the 7 over 3 squared, which is exactly the same thing as we've got over there. So what we do here is we just use the exponent laws to put those together first. Okay, and then it's like the very last thing I do is introduce the logarithmic form of that expression. So both of those work. I'll find that most people prefer the first method that we did, but this one works just as well. I'll tell you what. Let's do a log equation so that we've done both. I just got to find one on here. I want to find one that hopefully will work. fairly straightforward. Okay, I'll just grab the one that I saw just a couple seconds ago. Okay, so we like messy stuff. That's okay. Let's take a look at a logarithmic equation. Whoops. Log base 5 of x. Don't know why I did that. Okay, log base 5 of x is equal to 3 plus the log base 5 of x minus 1. Now, first thing to recognize here is going to be the restriction on the variable here. Okay, I've got a log base 5, got a log base 5 of x minus 1. The domain here is that x has to be greater than or equal to 0. Sorry, not or equal to. Greater than 0. Here, this has to be greater than or equal to 1. So the restriction ultimately, I said or equal to again, didn't I? Greater than. So this has to be greater than 1. And so that's going to give us a way of testing whether our roots work or not. Now, the way I've been telling my students to approach this here is what I want you to do is, first of all, get all of your logarithms to one side. Okay? All of your logarithms to one side, and then I want you to combine the logs together. Okay? If in your next step, the number of logarithms that you see in your equation gets larger, then you're going the wrong direction here. Don't distribute. There is no rule that says you distribute the log of 5 to both of those. So this becomes the log of 5, log base 5 of x divided by x minus 1. The subtraction right there becomes division. Subtraction between logs becomes division within a log. Okay? Once you've got it down to one log, the very next step should be to remove the logarithm. So we're going to convert forms here. We're going to convert this into an exponential form. So 5 cubed is going to equal x over x minus 1. Okay? So now the logarithm is gone, and that is my goal. When I'm solving a logarithmic equation, I want to get rid of the log. When I'm solving an exponential equation, I want to get rid of the exponent. And I use those tools back and forth to help get rid of that. So this is going to be, I'll leave it as 5 cubed times x minus 1 is equal to x. And I'll leave it as 125. X minus 125 is equal to x. So bring that over, 124, x is equal to 125. So x is equal to 125 over 124. Okay? Now, does that work? Is that bigger than 1? Yeah, it is. Just barely, but it is. And so that would be a feasible solution. That works. Okay. Anyway, so that's been, wow, 45 minutes here of us kind of hanging out here. The whole point of this really was just to check and see if this was something that would work for people. So just a little bit of quick feedback on here before we kind of shut this down. Does this work? Is this okay? There are other plans in the work to test. We're going to try something with Google Meet. We're going to try something called Zoom as well. Okay, yeah. So people are saying this works here. Okay, so my plan is then going to be, and this probably won't come to fruition until after spring break here. But what we'll do is we're going to try to make this more of a regular thing. Bear in mind, you've got your videos, the videos that I've posted, so you can keep up to date with those lessons. Hopefully, this is going to be treated more as a question and answer thing. Oh, sorry, I see a question here. So I'm not sure what you're talking about. Okay, with regards to the schedule, we got to work that out. We're love to go into polar curves. I would love to. Oh my goodness, Matthias. Maybe. I don't know. Anyway, that's a good point. That's a fair point. Okay. Okay. Anything else? Any other questions before I press end? No, I'm not doing Euler's number. Don't even try to tempt me. That's way too tempting and too much time. Okay, everybody. This will clearly not be the last time we do this. Everybody stay safe. I will be posting stuff, or I'll be sending out emails to my class to let you know when we do this in anticipation of this. So, all right, everybody, enjoy your day. Bye. No polar curves. Wash your hands. Yes, that's a good idea.